The leatherback sea turtle is one of only 7 species of sea turtles on the planet, but they look so different compared to the others. They do not have the visible scutes, they are darker in color, and they swim the fastest, dive the deepest, and inhabit the coldest waters. These differences are because the leatherback is the last turtle of a long lineage that started to emerge and separate itself from the other turtles about 100 million years ago. Since then, they have been filling in a niche that's so different compared to the other sea turtles. And so in this video, I'm going to tell you all you need to know about the leatherback sea turtle. The most notable feature of the leatherback sea turtle is the absence of the visible scutes and scaly appearance of the skin that you see in the other sea turtles. Instead of scutes made of keratin, they have bony plates called osteoderms. Their skin feels rubbery, and their shell is elastic and stretchable. This feature provides them with flexibility and helps them out with the pressure that is associated with their deep dives. Aside from their shell, their size makes them stand out compared to the other sea turtles. While most of the other sea turtle species reach lengths between 4 to 6 feet, which is still pretty large, leatherbacks average about 7 to 8 feet in length, and they can weigh between 700 to 1,000 pounds. So yeah, these things are massive. Having the largest distribution, they have been documented as far north as off the coast of Nova Scotia and as far south as the Solomon Islands. However, they do not stay put within a home range that is even remotely relatable to us. They are known to migrate tens of thousands of miles a year, farther than any reptile alive. During this time, they are known to clock speeds of up to 22 miles per hour, and they dive as deep as 3,200 feet. They can stay underwater for nearly 30 minutes before needing to come back up to the surface for air. This is not because they have a greater lung capacity. In fact, they have smaller lungs than the other sea turtles. Instead, they have more red blood cells and thus a larger oxygen carrying capacity, one that is actually twice that of the other sea turtles. Now, we know that they travel long distances to feed, and then they come back to the waters where they hatched, but there's still a lot of unknowns, particularly for the male leatherbacks, about what they do between the time they hatch and mate for the first time. In essence, we know they hatch out of their nest as these little 2-inch nuggets, and the females come back a decade or two later, having gained hundreds of pounds and reaching lengths of 8 feet. There's so much biology missing between those two times that researchers refer to that as the lost years. I want to take a break to thank you for clicking on my video. Millions of videos are uploaded to YouTube every day, so it means a lot that you stay tuned to watch mine. Please give this video a thumbs up or hype if you see it, or subscribe if you want to hear more from me. Thanks again, and let's get back to it. We do know that there are 7 subpopulations of leatherbacks, and these populations are separated by physical and behavior differences. The subpopulations may mingle while they are foraging for jellyfish, but because both males and females return to the shallower waters of their natal nesting beaches, the subpopulations do not mate with each other. And this has been confirmed by genetic analyses, which has shown there is no gene flow occurring between the subpopulations. Satellite telemetry data has shown that their movements can span across ocean basins. The destinations are linked to ocean currents, but not all turtles from the same beach have the same destination in mind. For example, females nesting on the beaches in South Africa had variance in movements that were influenced by ocean currents and other features that landed them to their foraging destinations. Half of the females that were tagged didn't go too far off the shore, and they foraged in the shallow waters of the Mozambique Channel in northern Madagascar. The other half went south, being led by the Agulhas current, but then they moved either eastward towards the Indian Ocean or westward towards the Atlantic. In the Atlantic Ocean, the leatherbacks that nested in South Africa were mingling with the leatherbacks that nested in Brazil and Gabon. The ocean currents assisted in their travels, but what drives their long hauls appears to be their food. Their favorite food is jellyfish, and jellyfish can be found all over the Earth's oceans, just like the leatherbacks. And they are weak swimmers, often found being caught up in the same currents leatherbacks are catching to assist in their migrations. So while it may seem like finding jellyfish in the ocean is like finding a needle in a haystack, finding them is actually kind of predictable. And the leatherbacks love jellyfish. That is primarily what they are looking for. They love jellyfish so much that some researchers have identified them as gelatinophores, or it's probably more appropriate to call them jellyfish specialists. However, this is perplexing because the only currency that really matters in nature is energy. So how is it that a 1,000-pound animal that migrates tens of thousands of miles, making it on a diet of something that is so low in calories? The answer is they make up for it in volume. One study from 2012 equipped some leatherbacks with video cameras and monitored them during foraging periods of up to 4 hours. This study reviewed the video footage and identified what species of jellyfish the turtles were eating, and then estimated the jellyfish's energy values. The study concluded that leatherbacks will eat 3 to 7 times their daily metabolic requirements and 73% of their body weight, and this is likely an underestimate due to the nature of this study. But other studies have estimated that leatherbacks will eat between 1,000 to 3,000 kilograms of jellyfish in a year. So you can thank leatherbacks for pretty much single-handedly keeping jellyfish from taking over the oceans. One feature that enables them to gobble up so many jellyfish are the papillae that lines their mouth and throat. Ever so often, the leatherback's mouth is circulated around the internet and presented as nightmare fuel. These are sharp, backward-facing spikes made of keratin. When they forage, the leatherbacks are gulping down the jellyfish and all the seawater that comes along with them. The backward-facing spikes allow for the turtles to expel the seawater out, but keeps the food in. The problem is that jellyfish are composed of a lot of salt water too, so the excess salt that they do accumulate is excreted through a gland that is near their eyes. While all sea turtles have these glands, the leatherback salt gland is more than twice the size of their brain. They need such a large salt gland to keep up with the large volume of salty foods they are eating to ensure they are maintaining their salt balance in their body. Now, this is something that is not at all surprising for an animal that has evolved to dive deep and eat really salty food. But one aspect that puzzles scientists is how the heck is an ectotherm able to stay warm in the frigid waters associated with their deep depths and higher latitudes at which they inhabit. Sea turtles are reptiles after all, and all reptiles predominantly warm themselves from external sources like the sun or sitting on a rock that is being warmed by the sun. In order to maintain a steady body temperature, especially in colder waters, the rate at which heat is being lost to the environment must be matched by the rate of heat that's being gained. So, how do they maintain a stable core body temperature when they are in frigid waters that are constantly zapping their internal heat? Well, first of all, leatherbacks have a countercurrent heat exchange system. This is where their veins do not carry cold blood to the heart and the lungs. Instead, the blood is warmed by the time it reaches the lungs and heart, and this keeps their body temperature on the warmer side. Other studies have also observed young leatherbacks increasing their swimming activity in response to decreases in water temperature. So this is kind of like us going for a jog on a crisp fall day and, basically gaining a sweat or bringing our body temperature up. The same thing is kind of happening for these young leatherbacks. But there's definitely more to the story. One study took a deeper dive to gain the full picture. This study found that a combination of behavioral and metabolic processes kept leatherbacks warm, despite the colder waters they inhabit. The study observed leatherbacks spending between 16 to 54% of their time at the surface, where the water is warmer. This gets their body temperature up to around 10 degrees Celsius warmer than the ambient water temperatures, and that reduces the overall heat loss they experience while they're on their dives. Additionally, metabolic rates depend on the thickness of their insulating layer, also known as fat, and also their rate of prey ingestion. When leatherbacks eat, they produce heat from ingestion, digestion, absorption, and assimilation. And I know that sounds weird because we have the tendency to actually feel colder after we eat, but with reptiles, they actually start to warm up after a meal. So for leatherbacks, their heat production really ramps up after eating, and provided they eat such a large volume of prey, they receive an uptick in their body temperature that keeps them warm in these colder waters. Depending on the degree of insulation, the heat produced by eating may account for 30 to 50% of their metabolic rate. So their visceral metabolic heat production plays an important role in maintaining a stable body temperature, especially while foraging in these colder waters. So basically, as they continue to forage, their insulating layer increases, right? They're getting fatter, so they are able to store more energy in their fat. And this decreases their thermoregulatory costs over time. And eventually that migration does come to an end, and both males and females trek all the way back to the shallow waters from where they were hatched to reproduce. Now, we don't know too much about how they know where to return to time and time again, but scientists have observed sea turtles coming up to the water surface and seemingly using the sun to orient themselves. Other scientists think it's some kind of magnetic thing, but it's likely that they do not use visual or olfactory cues to help them find their natal beaches. So we at least understand that part, but overall it's still a little bit of a mystery how they're able to travel these long distances and still make it back to their natal beaches. Most of what we know about reproduction is through the females, since they are more accessible to scientists, right? They're the only ones that are coming back onto the beaches. The males, after they're born, they never come back on land. So females, they reach sexual maturity between the ages of 7 and 13. And there appears to be a correlation between sexual maturity and carapace size. With leatherbacks, it seems sexual maturity is reached when the carapace is about 145 to 160 centimeters. Mating does not happen every year for a female leatherback. Instead, they appear to nest every 2 to 3 years. During the nesting period, they may lay a few clutches over a period of 3 to 6 months, spending about 2 hours to lay their eggs. These eggs are the largest eggs of any reptile, weighing about 80 grams on average. The sex ratio is dependent on the temperature of the sand. Cooler temperatures mean there are going to be more males, and then warmer temperatures means that there's going to be more females. All leatherback sea turtles nesting sites are in tropical and subtropical regions, so if you can imagine, with climate change, one concern scientists have is that the sex ratio is going to be totally thrown off to where there's probably going to be more females hatching with the warming temperatures. And since emissions are showing no sign of stopping, the excess heat that is caused by climate change may mean certain death. If sand temperatures exceed 32 degrees Celsius, it's pretty much 100% mortality for leatherbacks. But what really sucks for leatherbacks is their odds of survival. Their survival is pretty grim. On average, only 1 to 5 turtles will survive into adulthood. But for the longest time, that was good enough for the leatherback sea turtles to maintain healthy populations. So let's talk a little bit about what kind of odds are stacked up against them now. So humans, is that a surprise at all? Poaching is a really big issue. People like to eat their eggs, and this alone is the reason why there is a massive decline around South America. And the poaching happens pretty quickly after the eggs are laid. One study placed 3D printed eggs with trackers in some nests in an effort to find the poachers. And this study revealed that eggs are usually poached within 24 hours. Most baby leatherbacks will emerge from their nest at night, about 2 to 3 months after they are laid. For the longest time, they relied on the moon to guide them to the sea. However, humans again, we have built homes, hotels, shopping centers, walking paths, and so much more, equipped with bright lights that come on during the night, which confuses the newly hatched leatherbacks. For some, the brightest light is that floodlight that is lighting up the basketball court. And so the hatchlings go towards the city instead of the ocean. Some of the lucky ones will get assistance when they are found, but a lot of them perish as a result of choosing the wrong light to move towards. If they emerge in the daytime, seagulls take them out pretty quickly. If they actually make it into the ocean, carnivorous fish are looking for a meal as well. The scariest time to be alive is during the first few weeks to months after hatching. And because this is their most vulnerable time in their life, conservationists are working to ensure their survival rates are a little bit better. The Leatherback Trust is an organization out of Costa Rica, and they're working hard to protect leatherbacks in their little corner of the world. They have helped establish protected habitats at the most frequented nesting sites, They have education centers where they focus on educating community members about the role of sea turtles, coastal ecosystems, and even their economic value, right? Because people spend money to see sea turtles. I went to Costa Rica to try to find the leatherback sea turtles while they were nesting. I didn't find any, but I tried to time my vacation time specifically to see a leatherback sea turtle. And that brings in more sustained income than anything else. More pressure is being put on hotels that reside along the shore to go dark, so hatchlings can just follow the moon. A recent report from March 2025 has stated that many sea turtles across the globe are rebounding as a result of protections in place, but leatherbacks are actually still the exception. They still are not doing all that great. And if you want to learn more about what the Leatherback Trust is doing for leatherbacks, I left their information in the description box below. Otherwise, that's going to do it for today, guys. Thank you so much for watching, and let me know what bit of information was the most interesting to you. Like and subscribe if you want to hear more from me, and we'll just see you in the next one. Bye!